Elena, did you have any questions? Which one? Okay, so give me one that we can. 34. Okay, 34b. So when it says the integral from 2 to 6 of g of x dx, that means find the area between the curve and the x-axis, between 2 and 6, okay? So that's from here to here. So that region is a semicircle, I believe. So I'm going to find the area of the entire circle by going pi times the radius squared. So that works out to be 4 pi. Like I said, it's a semicircle, so half of that area is 2 pi. And even more excitingly, since it's below the x-axis, it's going to be negative 2 pi. Okay? What do you guys think about that? Uh-huh. Right. Right. Gotcha. Okay. Does it make 2 to 0 be 4? Yes, because this from 0 to 2 is a triangle with a base of, 2 times 4 is 8, half of 8 is 4. Yeah. Yep. No, they give the graph for you. And then this, yeah. Yeah. Why's the answer what? Tegan, how'd you get 4? No, neither. Just doing the whole thing. It's the area of the, just find the area of the triangle. No reason to break it up into rectangles because we know the formula for the area of a triangle, so I don't have to do that. I can just find it. Okay? So for C, now we're going the whole graph, right? So you figured out that this part was 4, so that's that. Elena and I figured out that this part down here was negative 2 pi, so that's that. And then since we're going all the way to 7, there's this little half square right there that we have to add on, so that's that. So altogether, it's 4.5 minus 2 pi. Okay? This piece minus this piece plus this piece. Okay? Elena, solid? Okay. What? Or plasma? Oh. Shaden? 33A says from 0 to 2. So like Mason said, the graph is on the next page. So that means I'm going to find the area of this shape right there. Okay? Which you can do as a trapezoid, or you can pretty much just count the squares. 1, 2, 3, 3.5, 4. Okay? Pretty much going back to geometry. Katie, what's your question? 35? 35 without Desmos. Challenge accepted. I guess that's far enough. And I want to go from 0 to 3. So how much is this? That's 1, but it's below, so it's negative 1. And then this is how much? I believe that's 1/4, because this is halfway up the square. So 1 times 1/2 is 1/2, and then since it's a triangle, you have to cut it in half. Yep, so that's 1/4. So this answer would be -1 plus 1/4 equals -3/4. Mic drop. Did it without Desmos. Thank you very much. I'll be here all week. Mason? Oh, yeah. Right. Plug in 1, 2. Oh, yeah, we're not going to do it using areas with much more complex shapes because I do know what you mean. Yeah. Yeah, we're gonna have a formula real soon. Okay. Shaden, any questions? 36. Okay. So 36. I know this is not something that you guys know right off the top of your head, but the square root of 4 minus x squared is a semicircle with a radius of 2. Okay? And so if I'm going to go from -2 to 2, that's what I'm here for. 2 squared is 4, so the area of the whole circle would be 4 pi, but then, yeah, we only want the above the x-axis, so it's 2 pi. Yeah. Okay? Okay, 37 is a great question. Let's go ahead and jump to that, because what Payson is assuming here is that this is a semicircle with a radius of 3, which is correct. So the whole circle would have an area of 9 pi, right? But you have to look at you got to kind of really look at the graph here. Right, so for one thing, it's from 0 to -3, okay? This one? What does adding 1 to a graph do to the graph? Moves it up 1. So this is going to be a semicircle with a radius of 3, but instead of being on the x-axis like this, it's going to be up like this, because it's the square root of 9 minus x squared. The general formula for circle is x squared plus y squared equals the radius squared. So if you solve that for y, it's y squared equals r squared minus x squared, which means that y equals, for the whole circle, you have to go plus or minus r squared minus x squared. And if you try to change that into r minus x, I will find you and I will try to reteach you so that you understand the error in your ways. Okay, this is all it is. So if I look at this, then 9 minus x squared, the radius is 3, right? Because 3 squared is 9 minus x squared, okay? The way you get a whole circle is if you go the plus and the minus. This is the positive square root, so it's only the top part of it. If I wanted the part... What's that? So the reason why this would be the whole circle is because I put plus and minus there. But if you only do the plus, then it's the semicircle above the x-axis. If you only do the minus, it's the semicircle below the x-axis. Okay? Okay, anyway, so what we got going on here is if we're going from 0 to -3, we only want this stuff right here. So I want 1/4 of the circle. So what's a... Right, so I need to take this and divide it by 4, plus, what's the area of this right here? 3. Okay? So when you said take the whatever and add 1 to it, that's not how it works. Okay, because it's now sitting on top of this rectangle, so you have to add the area of that rectangle. Gage? Okay, duly noted. So now that you and I have that worked out, if I put this on a test, just don't bother doing it, because I'll know to just mark you wrong. You don't think, like, if I gave you square root of 16 minus x squared, you could, like, go, oh, circle radius of 4? Okay. Well, we're still working on it. Oh, okay, good. So this would be a good little review for us. These are graphs that you guys should know. Payson? Yeah, I don't disagree. Hero, did you have any questions? I got to turn it up a little bit. It's a little chilly. I'm trying to accommodate you by managing the heat better first period, so it's not so hot when you come in here. Okay, can you reach sort of a middle ground? Uh, Hero, what'd you say? Okay, so you're good? Okay. Okay, what's your question? Well, this one turns out to be not the semicircle, it was just the quarter circle because it's going, right, and just divide by 2 because it's just half the circle. Because it's only a quarter of the circle because I'm going from 0 to -3, okay? Shaden? Because we're going to what? Oh no, it'll be straight down. It goes from x equals -3 to x equals 0. Anything? Right, that's right, yeah. Is it about this one? Okay, what? Well, what Katie's just figured out is since I gave you the formula for the area of a circle, or for the graph of a circle, this is going to be the radius squared. So to find the area of the circle, it's always going to be this number times pi. So this one over here, what's that? It is 4 pi to start with, but then we're only doing the top. So then I had to cut that in half, and that's how I got the 2 pi. So 4 pi is the area of the entire circle. But then I have to look at what I'm being asked to find and figure out what fraction of the circle do I want. So in this case, since I want from -2 to 2, I want half the circle. In this case, since I only want from -3 to 0, I only want a quarter of the circle, so I divided it by 4. Maybe. Never say never. Tegan, did you have any questions? Absolute value, the bars. Okay, what you got? Uh-huh. Plug this into the, oh, and make a graph that way? Yeah, yeah. So basically just make a table. Okay, what number had absolute value, Tegan? 39? Oh, all right. Well, I didn't copy those down. So what does it say? What's 39? Integral, uh-huh. Integral 2, okay, from -1 to 2. Okay. So you guys probably maybe don't remember what the graph of the absolute value of x looks like. Yeah, it's just a V-shaped graph. So if I'm going from -1 to 2, I got a little triangle here, and I got a bigger triangle right there. And I just need to find the areas of those two and add them together. Well, since it's just x, the height is going to be the same as this. So this height is going to be 1, and this height is going to be 2. So this is an area of 2. This is, yep, an area of 1/2. So add those together, and you get 2.5. It's above the x-axis. It is to the left of the y-axis, but we don't care about that. Yeah. And just do the algebra one. Yeah. Right. Yeah, the trig equations. We're doing trig equations in pre-calculus. Right. I don't know why either. Uh-huh. Right. Right. I've always known as a math teacher that there's some people that are really good at algebra, some people that are really good at geometry. There's some people that are good at both, but it's just a different. Yeah. Tegan, does that help you? And I was gonna say you got that one. What is it? Quarenta. Um, Tegan, do you have a question about 39? Okay. Do you want me to do 40? Okay. What's the equation for 40? Opposite value of x minus 5? Okay. So the reason why these are so much fun is because you get to review all of the graphing rules that we talked about, like in advanced algebra and with other teachers beforehand. No, because it's inside the parentheses, so it moves the graph 5 to the right. Nope, to the right. Inside the parentheses is opposite. It is. Absolute value behaves a lot like parentheses. Okay, so if I need to go from 0 to 10, then I got myself a triangle there with a base of 5 and a height of 5. And then I'm going to have another triangle over here with a base of 5 and a height of 5. Yeah. Because it's moved over 5. So maybe it's easier to see this on Desmos. So since it's moved over 5, when I go over to 10, then I only go up to 5. If it was scooted over here, then it would be all the way up to 10, right? But since I move it over, so it's 5 here, 5 here, they're symmetrical. So you could make a square out of that like Payson did and just say it's 25. Okay? Mason, do you have any questions? 38. Yeah. Yeah, y-intercept. Yeah. I mean, flip it around, right. 1, 2, 3, and then down 2 over 1, down 2 over 1, down 2 over 1. I guess I want to go from negative 1 to 3, so it's this right here. So I have one triangle above the x-axis from there to there with a base of 2 and a height of 5. If you need to know what the area of that is, ask Tegan because he's money with triangles, I've noticed. And then this one over here, oh, no, I lied, because this goes through its base of 2.5. And then this one has a base of 1.5 and a height of 3. So you find those two areas, subtract the smaller one, and that's your answer. Does that make sense? Want me to, yep, what, because it's below the x-axis, so it's negative. So the area of this one would be 5 times 2.5 is 12.5, cut in half is 6.25. And then the area of this one is 4.5, cut in half is 2.25. That was weird. But then I have to subtract it, so the answer is 4. Okay? Easy, easy. Like I could teach this to sophomores in geometry, right? And just say this funky symbol just means find the area, and then just draw the shape and find the area, and you'd be like, yeah, okay. Okay, we're getting there. Like it said yesterday 3 or 4 times, easy formulas in the next section. Which one is going from pi to pi? Yes, if it's from pi to pi, then that would be 0. Yeah. So they're trying to trick you with this one by giving you, they're not, I'm sorry, I should never say that. They're not trying to trick you with this one. They're trying to make sure you understand by giving you what Mason would look at and go, oh my God, that's a totally crazy, weird trig thingy. How the heck am I supposed to graph that and find the area underneath there? But from pi to pi is nothing. The base is 0. So the area is also 0. Okay? Okay? No, it means the area from pi to pi underneath the curve sine squared. Yeah. My dude, that's funny that that came up because I just saw him in a commercial. Gauge? Okay, sweet. Are we done? Okay. Okay, so let me take those from you. It's okay if you don't understand how it works. Okay, so here are some things that you need to know about the integral that came up already in your assignment, and we didn't talk about one of these, so I'm going to have to go back and fix some damage that I did. First of all, if you do the integral from b to a, and then you switch that around and do the integral from a to b, it's the same thing, but you make it negative. All right? So if I'm trying to figure out the area of this semicircle from -2 to 2, and I get 2 pi as an answer, so that's the integral from -2 to 2. If I am asked to do the integral from 2 to -2, that is going to be -2 pi. Okay? Hang on just a second. And so I kind of lied to you because this came up in one of the problems and I saw it and I thought, oh no, it didn't come up, never mind. I thought 37 was that way, but it's not. Okay? So if you switch the order of integration, you just change the sign of the answer. Yeah, well then this answer would come up negative and this one would come up positive, but this would still be the opposite of it. It's not saying that the final answer of this is always going to be negative. It's just going to be the opposite of what this one is. Yeah. Good clarifying question, Payson. Thank you. And then we just did this one. If the limits of integration are the same, then it doesn't matter what curve you're finding the area under. It's still going to end up being 0. Okay? All right. So are these important enough for you to write down? No. Number one is just saying if you take the integral of a number, if this is just a number, like give me a number. 6. Okay, the graph of y equals 6 is just a horizontal line, right? So then if I want to find the area beneath that curve from A to B, well this is just a rectangle. Yes? And the base of this rectangle is going to be b minus a. The height is going to be whatever you guys chose for that, which you guys did 6. So then it's just c times b minus a, which is basically base times height. Okay? Yeah. All right, then these are pretty obvious, but math people always want to make sure that they're explicitly stated because there are, every once in a while, cases where they're not true. If you are trying to do the integral of two things added together, you can do the integrals of each one separately and then add the answers together. That also holds true with subtraction. And then if you're trying to do the integral of a function multiplied by a number, this is actually really important. We're going to use this a lot. You can take the number out and put it in front of the integral sign, figure out what the area is underneath the function, and then just multiply it by that number instead. Okay? Good. I'm doing my job well then. All right, so I don't want to do that. Okay, this is also fairly obvious, or should be. Let's say that I have a graph that looks like this. If I was asked to figure out the area, the integral from A to B, hold on to your hat. So you ready? That is the same thing as the area from A to C plus the area from C to D. Okay? So the area underneath the curve from A to C plus the area underneath the curve from C to D is the area underneath the curve from A to B. It's just kind of a transitive property. Yeah, I know. That's that one's rough, Mason. We can talk about that later. So, for example, if you know for some curve the area from, or the integral from 0 to 10 is 17, and then you know that the integral from 0 to 8 is 12, what's the integral from 8 to 10? 5, because these two pieces have to add up to the whole thing. All right. Okay. All right. Okay. Then that's just weird, random stuff. All right. Okay. So you guys are ready for the good stuff now? What time is it? Oh no, it's 9:57 already. Never mind. Yeah, assignment. Yeah. Yeah, I'm giving you an assignment. Yeah. She also used to.